think we're all as ready as we'll ever be, Daniele, for our next talk. We will hear from Daniele, who is not only the conference director of this very lovely and wonderful conference, and is not only involved with also running a couple of other conferences and assisting people from all over the Python and Django environments with their conferences. He has also been involved in the whole ecosystem for a terribly long time, especially also with the Django communities and the Python community in Africa, as you probably all know, because you've seen him at this conference a lot. Please give him a very, very warm applause.
Thank you, Tobias. I'm wearing a headset microphone, which always makes me nervous ever since EuroPython, where I put mine on and nobody told me that it was sticking up like that. So I've never been able to watch the video where I gave a keynote at EuroPython because a bald guy with something sticking out of his head like that looks absolutely ridiculous. So I'm assuming that looks okay. Thank you. Okay, I'll quickly tell you about me. I'm Daniele Procida. That is what I look like on television. I work at Divio, where we have a cloud hosting platform, and the basic idea of it is that you sleep and we drive. You can come and talk to me about that later. So I've been with Divio for 5.5 years now, and they've been extremely good times, mainly because they have so generously allowed me to do things like this and the other conferences and things that I'm involved in. So I'm very happy to talk to anyone about Divio as well. I'm a core developer of the Django project, and I should emphasize the ex-vice president of the Django Software Foundation. I'm no longer doing that, although many people seem to think I still am, and sometimes I think I forget it myself. But anyway, I get lots of people sending me queries about Django cons and can I decide this and that. And I can't do that anymore. I have no power there. I'm no longer on the board. So the new vice president is Anna Makarudze from Zimbabwe. But I'm still very much involved in the Django community. It feels like my extended family, and I'm happy to talk to anybody about Django too. At any time, anywhere, you can email me. I don't really use Twitter because I think it's a fairly unsatisfactory form of communication. But best of all, just come and find me and talk to me. I really enjoy that. You've probably encountered axial pen plotters which draw. They move a pen on an x-axis and a y-axis and lift it up and down, and they can draw things. And this has probably cost a lot of money back in the 1980s, this Roland pen plotter. And I asked myself the question, what is the cheapest, simplest pen plotter that could possibly be made? Well, I think I've made it. And here it is. And what I'm going to do is, I'm going to show it to you live right now. We've got the camera set up for that. It's called brachiograph, meaning arm writer, from the Greek. Brachion, arm, and grapho, to write. And there it is. So what we'll do now is perhaps we can switch over to the video camera. And, oh, okay, sorry, this takes a few seconds every time. I should plan this more carefully next time, because I want to show you what I'm typing as well. So there's the actual device as well, and you'll be able to have a chance to come up and see it more closely. Sorry, can we switch back, because I meant to show the terminal. So let me come out of here, and I'm going to jump into one of my terminals. There we are, and you can see my screen, and I hope that the text is adequately large. Let me make this full screen. That would be okay. So it's powered by a Raspberry Pi. So everything runs on the Raspberry Pi Zero. I'm actually here. This is not very big, is it? Can you see it at the back? You're free to come forward, and no one's ever been bitten by a speaker at PyCon UK so far, which doesn't mean that it could never happen, but I'm all wired up, so you'd see me coming. I'm in my terminal on the Raspberry Pi, so everything will happen on the Raspberry Pi. I've got some software. I'll show you the software in a moment, but I just want to get it started going so we can see what's happening. And now I have to talk and program at the same time, which is, I managed to type Python correctly. Good. So I'm going to import my brachiograph instance, and I've just created a little file called bg with some saved instances, import bg2. So this is, I've got a couple of them saved in there, and this is an instance of the model in the Python software. Give it a moment. Now you'll, okay, well, the pen is going to, good. It's just parking itself, right. Now what I'm going to do is I'm going to plot a file that, from an image that I vectorized earlier. So there's my bg2 instance, and I'm going to use the plot file message. And actually, it's not this file. It's a photograph that I took of a building in Prague, and it's actually a JPEG. And if I've got that right, this is going to start. Good. Oh, damn! We need to switch the camera quick. I forgot. Please don't record me swearing. It doesn't look good. Okay. So here's the plotter plotting, and what we have here, I'll point out to you the parts. Perhaps, Tim, could you be my camera person, please, so we can zoom in a little bit on and get a closer look at some of these things. We've got two servo motors. So this is the shoulder, if you like, and that's the elbow. Okay. I mean, maybe even hand hold it so we can get it from different angles. Okay. So this is the motor at the shoulder. It's a servo motor that costs about £3, and this is one at the elbow, and they both rotate. And then this one here, if you can show that, this motor over here, that lifts the pen up and down when it's not supposed to be drawing, and that's a clothes peg, as you might have recognized. And I just found a pen in the committee room. Here's the Raspberry Pi Zero. It's a completely standard Raspberry Pi Zero, apart from this little shim for turning it on and off. And perhaps you can see that it's starting to draw the shape there. I think we can put the pen back there. So this is going to take a while. It's not the fastest or most accurate plotter in the world, but that was never the point. This version is made with a couple of little wooden sticks that I found in Poundland, but you can just as well use stiff card. So you can actually make it with a clothes peg and two pieces of card. I've got a version of it in the office there that is, or here, I put it down somewhere, doesn't matter, that is just made of that. The clothes peg is handy. That's nice because it means I can swap in a pencil or a different kind of pen or even artist's charcoal. So I've had some nice pictures from artist's charcoal. And with a pen like this, it doesn't need a weight. If you use a ball pen, then you need to put, I put my box down somewhere, haven't I? Never mind. I put some little bolts on the top of the pen to, it's okay, Vincent, thanks, to make it, make a mark on the paper. So let's leave that drawing, and then we'll switch back to the display. So here we have, it's about 8% of the way through. So what I'm going to do is I'm going to switch back to my slides. Not like that, some other way. Like that. Okay, so here's my brachiograph. You can see the parts. I don't know who I stole that pen from, but I really like it because it doesn't need any pressure on it. So what it's made of is two arms, two joints, and many triangles. You can see them all in there. And there's the actual thing and the kind of mathematical model side by side. So I hope you get an idea in your heads of how this works. Instead of being an axial pen plotter that uses x and y axes, of course it has to use x and y coordinates to know where to draw, but the software translates those coordinates into the angles of the two motors. So it involves a little bit of mathematics. Here's a close-up of the mechanism for lifting up the pen. I do apologize that so many of these images that seem to be here seem to be of me. And it's not because I'm a narcissist, or I might be a narcissist, but that's not why they're the images of me. It's just happen to be easy images to use. Here's the mathematics that's behind it. It's not beautiful, but it's actually reasonably simple. It's high school trigonometry, so it came back after a bit of headbanging. There is some of my work. Oh God, there's me again. It was one of the first things I drew, and it turned out to be quite a good picture, that's all. So as you can see, it took a bit of working out. Here's my bill of materials. So we have the Raspberry Pi Zero, which is, I've put the prices in dollars. I meant to change those to pounds. I think it's £5 anyway, the Pi Zero. 1-to-1 now anyway. The 3 motors, which are about $3 each. If you buy fake ones, they're the ones which cost about less than £3, and the real ones are usually more than £3, and I discovered this the hard way. So I've got 2 real ones there where it matters, and that's a counterfeit one there that will burn out at no notice whatsoever. The other things I use, stiff card for the base. You can get that by going to a framing shop and saying, do you have any card you want to dispose of? And they say, here, I'll have this huge bag full of it. You need stiff card or sticks for the 2 arms, glue, a clothes peg, and a pencil or pen or other implement. And I didn't put the prices there because all this stuff can be stolen, and you're very unlikely to be punished for it because it's very low value. Actually, that's not. I shouldn't really be recommending that. I mean, obviously, the Raspberry Pi stuff you should buy, and people do say, you can get away with stealing stuff of low value. And that's really bad advice because it's not true. You can get away with stealing stuff where it's more trouble for them to punish you for it. So actually you can, if you want, you can steal very high value things as long as it's more trouble for them to punish you than it's worth it. So for example, fraud is a really good crime to commit because often you expose other people's failings by committing fraud. And you can get away with a huge amount of theft that way because it will cause other people much more trouble to. That's so those are all. I mean, most of them you can find in a kitchen, for example. The only thing you need to be aware of is the glue because you get in trouble if you stick it on the kitchen table by mistake. And the tools are a knife to cut the card and a ruler. Now, to convert a photograph into material that I can plot, what I need to do is get a bitmap image, a photograph, and then I've got a routine to vectorize it. I use a library called LineDraw, which I found, it's a very old one, it was written in Python 2, and I've very substantially changed it and put it into the library for this now. I just found it on GitHub. I don't know if it's the best one. It was the first one I found, and I'm rather lazy, so that's what I chose. And it vectorizes the image. So here's an example where we've got a photograph that I vectorized just to find its contours, and then there's the output with drawn with a stick of artist's charcoal, and that's one of my sons, actually. So, and this is actually what we're drawing now. This is the building in Prague, which seems to be coming along reasonably well over there. The vector image and the output. My scanner doesn't really do justice. Here's one with a soft pencil. This is a lighthouse in Dorset. And again, with charcoal, here's a Fiat I found in Florence a couple of years ago. So you can almost recognize that it is, in fact, a Fiat. How are we doing for time? Yeah, okay, we're doing, I'll very quickly show you, can we switch to no, don't switch. Is it too late? No, good. Okay, let's go back to where we were. I want to show you how I vectorize things. Now, this is tricky, and it's tricky because it involves me remembering code. Ooh, that didn't look so nice. That's probably because it gets upset when you change the screen resolution. So this is, I've got the LineDraw script imported here, and what I would do is I would choose my image. So let's say, let me go and find you the image so you can see what I'm talking about. Here is the wrong one, and that's the wrong one also. Let's go find the right one. It's it is the right one. I was looking in the wrong place. Okay, so for example, supposing I take this image here. That's the image. And what I will do is, you can go away now, I don't need you anymore. What's it called? It's called Prague.jpg. So in here, so what I've done with the line draw library, I've adapted it to make it more suitable for my purposes here. I can control whether it draws a hatch, that is to fill in the, to cross-hatch it, to fill in the shaded areas, the hatch size, whether it's going to find the edges and so on. So let's just do a quick version like that. This will be very quick. And it's finding the edges. I'm doing this part actually on the Macintosh just because it takes a long time to do it on the Pi, and the Pi is quite busy already. It uses just NumPy and other libraries. So that now gives me, you will recognize this as the same thing, and of course the more perceptive amongst you will realize that that is also the same thing. It's JSON, it's just a series of coordinates. And then I send those coordinates onto the Raspberry Pi and tell it to plot them. And it's reasonably smart, and one of the things I'm quite proud of is that if the drawing area is landscape and you send it a picture that's in portrait format, it will automatically rotate it to maximize the drawing area. So that was my clever achievement of 2019. We could do it slightly differently. For example, here, I could draw hatch equals true. And this will take a little bit longer because it's got to do all the coloring in. And it can get up to, at the moment, 4 levels of gray shade by the amount of hatching it does. So that's going to be finished in a moment. How am I doing for time, Tobias? Okay. There we are. And let's have a look at the output now. Why did I not? Oh, there's Prague. That's the one with a bit more shading on it, you can see. The further you are away, actually, the better it looks. Okay, I'm going to go back to my presentation now. And this is an earlier version I made, a pantograph. And it was more complex. It had a different arrangement. This is a pentagonal pantograph, and also made of lots of triangles. There are some advantages to this, but this newer version is simpler. This is how this is some output from this. This has got more expensive motors, so you can see how nice and straight the lines are, whereas on these ones are quite shaky. But I destroyed those motors, so I can't use them anymore. I destroyed quite a lot of servo motors. So you can actually get really good results just by spending a few more pounds. So improvements. Well, can I make this more precise? Well, yes, by improving the motors. I went a bit mad at one point. I thought, okay, you know, Italians, we're really good at engineering. So I made this fantastic box structure with cutouts and so on. I thought, I want this to be as rigid as anything. And it was, but I, again, soon realized I was heading off in the wrong direction of more precision and making it better. And making it better is not, or making it more precise is not what I want. Because for my purposes, that's not better. I don't want to make it more precise. I want to make it simpler and cheaper and easier to build and reproduce. So it's been with me, for example, to PyCon Namibia and PyCon Africa. And the people that I meet there don't always have laser cutters and 3D printers in their hack spaces and university laboratories. They have fewer resources. So they're very resourceful and can do all kinds of things with what they do have. But if you give them instructions that starts with your 3D printer, they're going to be a little bit stuck. So simplicity and cheapness are the key here. It's all, there's a GitHub repository with all the software and pretty good documentation for it too. I want to show you one last picture, I think. Okay, this is Ben here in the audience? No. So this is us at EuroPython, when everything went wrong just before I did it. First of all, the Macintosh wouldn't SSH into the Pi, so I couldn't control it. Then we had some problem with the camera. and we couldn't get anything working. So I just had to keep calling people out of the audience. Somebody who had a special keyboard that nobody else could type on but him because it only had 4 keys on it or something like that. And he was typing blind into it. And Ben is being the cameraman, and we jiggled together some software, and we managed to do the demonstration. And I just had to stand away from it and just conduct. I think at one point there were 4 people on stage driving the thing for the presentation. Let's switch back to this so we can see what's happening. And while this is going, I'm going to say thank you for listening to that, because I'd love to have any questions and talk to you. And I've got some pictures here that I'm going to put out on the front. So thank you very much. Tell me what you would like to know about this, and I'll see what I can do.
Thank you, Daniele. Time for a couple of questions.
You've got a peg holding the pen. Pegs are quite heavy. How does the objects on the end where the pen is, the weight of those affect the drawing? Do they affect it?
Okay, that's a really good question. I was really worried that too much weight on the end would upset it, but for materials, for implements that don't draw as well as this pen that doesn't need much pressure, I put quite heavy weights on there, and it doesn't seem to upset it at all. So with a ballpoint pen, where I've just got the tube of the ballpoint pen sticking through the card, I put a stack of bolts and magnets on there to put down as much weight as possible. So these motors are fine, and the heavier motors are really powerful and can deal with it without problems.
Other questions? Yeah.
Meanwhile, I'm going to put these here so it's easy for people to see some of the artwork if you want to come see that after the talk.
You mentioned that you wanted to make it cheaper and easier to reproduce, right? Instead of making it more precise. What about making it faster?
You can make it a little bit faster. So what it does right now, it interpolates. If it knows it has to draw from here to there, then it will. This is really a really interesting problem, because if I just draw from here to there and tell the motors to go from the 2 angles needed here to the 2 angles needed there, it won't draw a straight line, it will draw an arc, because the motors, it works on radial motion, not axial motion. So I have to break down every line into small pieces anyway, so it's always actually zigzagging along the line. You can't actually see the zigzags. The wiggling here is not from my zigzags, it's just from the inaccuracies in the motors. So you can make it faster, but the results are less satisfactory. And you can end up damaging things because it's whacking the motors around. And also, it's good to wait. Everything happens so fast nowadays. You take your photograph, and then 6 million people see it in the next 5 minutes on Instagram. Whereas this, we could actually attach a camera to the Raspberry Pi, and it would be the world's slowest, most inconvenient camera. But we could do everything from a button press to producing the image. And I think people should learn to be more patient and sometimes bored as well.
Quick last question.
So you talked about the fact that you wanted to make something that was cheaper, and obviously you've hit something like $12.50 now, or whatever it was, so you've got pretty close to that. Is there anything you'd like to do next with it, or do you feel like you've sort of, it's a nice complete state and you're happy with where it is right now?
That's a really good question, because I kept thinking that I'd made it as simple as possible, first with the pantograph with its forearms and its hinges and so on, and then with the previous version of this one without the peg, which is actually still the main one featured in the documentation. So it could be that I'll find something else, but it's hard to see where I can't get away with fewer motors, for example. I think that this is now really easy to build. You just need glue and a knife and a ruler. It doesn't get much simpler than that. I want to make sure that in practice it turns out to be really reproducible. For example, if somebody's trying to build it with their child at home, because you don't want to promise people things, you say this is going to be easy and simple and so on, and then they get a disappointing experience. So I'm sure the software could definitely be made more understandable. I'm not the world's greatest programmer. I'm not the greatest programmer in this room by any means. I'm not even sure if I'm the greatest programmer on this stage. But the software could definitely be improved, but I've written it in a way that I thought would be easy for people to understand, and being able to understand it is an important part of being able to reproduce it.
Let's thank Daniele once again.
Thank you very much. Please come and have a look at come and have a closer look. Have we got time for people to have a closer look in 2 minutes before the next speaker comes on? If you're super quick, yes, let's do that. Thank you.